London next week. Yeah.
Oh, really? My
Just,
roommate
one more week
used to
in
do
Las
that for
Vegas,
us.
and then I go back to Texas for a bit.
Hooray.
So you are in for right.
Isn't not too bad.
Nice.
He's going to Croatia.
It's pretty cool.
You don't reckon
He said he's able to do a trip to Croatia and Budapest and Austria for $1,500 total.
That's pretty good. What?
For the flight,
Yeah, like for everything? Or?
everything.
Oh, wow.
No.
Well, he's staying at Utah, so that's like
Yeah.
20 bucks a night.
Oh, it's like 200.
But he said all in his cost.
Unless you're in people saying that.
Oh, and that includes, I guess you got a Eurail pass for 50 bucks. He also got a flight from Croatia to Budapest. So it was super cheap. It was like $250 or something.
That's really good. Like, it costs more to, like, fly, like, I'm here, like, Texas.
Yeah.
You're from here or?
I don't know what I'll say. It's gonna be.
No way. What part?
Good luck.
500 global guests.
Yes, 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 yes.
Yeah.
Like Pasadena or?
Have you tried the soft
I'm
rice?
so sorry.
No, it's basically like, I've just been busy with work and, like,
I'm from, are you familiar with like South Beach?
and, like, we could
Glendale?
Oh,
Okay, I'm from like around there.
It's been kind of nonstop.
I love meeting people from LA. Like we all
I didn't realize
gravitate
the
here.
process was being started so early.
Yeah, like, I saw it,
Do you
like,
see
last
yourself
month.
living here?
Well, no, probably the month before, actually. We're already at, like, you know, like 85 something. Really bad
No,
things
there
these days.
Wow.
Like, I thought it was like a me problem, but then I talked to like people like like 2 years ago, right? And I was like, yo, I'm not getting responses. Am I doing something wrong? They're like, okay, let me see the message, let me see everything, and then they're like, I don't understand. How like we got so many OAs back then. Like I'm not even getting like the OAs for like all the positions.
Yeah, when I was at Nutanix, I opened a job for a data scientist intern. I got 888 applicants in one.
Yeah. I am one of those applicants these days. I mean, like a lot of places don't do it. It's like so many places like for me don't big applications. I'm just like send out like what like 5 a day. And then we get.
Hello?
I've only gotten like maybe like 5.
Hi guys, people are still coming in, so we'll start in about maybe 10 minutes or so, but help yourself to pizza, water. The Wi-Fi password is like over there. You see some QR codes on there. And the bathrooms are back there, just through the door. And you gotta sneak your way through the hallway.
You should just put it on the screen now.
Yeah, it's not cool.
So you don't think you'll do an internship at the same place?
The thing is, it's like it's a little pre-seed stuff, you know. I want to, but like, also realistically, I should because I'm still in college. I was thinking I'd probably get more experience like elsewhere too. Kind of get to try everything before like I walk into one place. Cause like it's a really nice like culture. Like I've won a lot there this summer. It's just like at least like everyone's also been telling me like because it's such a small startup, I should go try like the one and see how that goes. They're just really hard to get into these days.
Or you can do definition larger company, but I mean, it's more than 800 people. No one enjoys being part of it.
I mean, like, because I have lots of those. It's just like, I don't expect anything to happen from those.
By the way, I asked some Tesla. Oh yeah, it was you. Tesla stickers, right? Or
Oh yeah.
yeah. Okay, so anyone that wants a PV sticker, put it on your phone, your computer. Have someone that's helping to pass it out. So, you know, just offer up your computer or whatever. He'll help you.
I'm just like thinking about anything that's not good in my company, which is like people.
Well, it's actually a power law distribution. So we're looking at
Like the chick that
the number of companies that use so you just do like a certain amount of the number of companies and their taxes budgets are you know, counting employees. Remember, it's small companies, for example. So if you look at the number of companies over 5,000 employees, it's very small. So,
Have you made money?
Making fun so hard.
Thanks, pretty helpful.
How you do?
Yeah. So you're looking to do analysis and like make normal graphs?
Actually, I don't have
so tell me what you're looking for.
I thought it
So I can filter by, so, okay, so I'll clear my filter. Okay, so you're looking for companies, what you got?
Yeah, you guys did. Yeah. Like, this might be like an ignorant question, but like, is like the state industry have, is it like something you do like when you walk, or like just out of the
Apollo.
Oh, I see.
So I can search for, yeah, so what's the number of employees?
More than 10?
Okay. That's the range. So, that's how I know that.
Yeah, not fun.
I've been following along. So now it's got this line up. So now you want the company. What about you? Let's talk to you. Location. Okay. So now we narrow it down to
Yeah, that's true. Like, definitely technical.
okay, so industry.
Station's right there.
So search industries.
I just long weekend last week and everyone checked.
Construction, software.
Sounds great. Feels something.
Nice to meet you.
Doesn't really matter after that. Like, it's more about like, I guess if the projects are interesting to work on, like the particular field. Like,
Now we're down to 13,000. But you want companies that are growing. You don't want companies that are right now, right?
yeah, that's true.
Okay, so we can look at growth rate, headcount growth.
Okay, can everyone hear me okay? It sounds a little bit muffled, but... Hello? Can you hear me? Is this better? Okay. Well, first of all, everyone can hear me? No? Down and out? That's better? I don't know. I'm trying to figure out how to down this way? Yeah, perfect. This is better? Okay, okay. Much better. Okay, great. So guys, thank you guys for attending our launch event presented by Tool House. Really happy to have everyone here. Let me quickly go over the agenda. So it's only about our agenda. The bulk of this is actually networking. This is actually very important. So first, welcome. I think I kind of went over logistics, but for those of you that weren't here, the bathrooms are in back, so just kind of go through that door there, and then you kind of snake around. Yeah, there's plenty of pizza. Help yourself. We have water here, and yeah, just enjoy yourselves. Really happy to see everyone here. So, let's see. So the first speaker is Jürger, and I have a little bio I'm going to read. Just give me a second. So, Jürger researches AI's impact on developer productivity at Stanford. Actually, before I do that, let me just read over the rest of this. So yeah, Jürger's going to do this, then I'm going to go over prompt-driven, give an overview of that, and then I'm going to give a head-to-head demo of PDD versus Cloud Code. Anyone here uses Cloud Code? Okay, for you guys, that's awesome. And then Danielle's going to give a overview of Toolhouse and a demo. Then I'm going to end with a kind of migration demo of using PDD, and then we do some networking. Now let me read the bio for you now. So Jürger researches AI's impact on developers' productivity at Stanford. We analyzes data from over 100,000 engineers across hundreds of companies. He also advises global organizations like the World Bank and the United Nations on creating labor policies for the AI era. So please welcome Jürger.
Thank you, everyone. Pleasure to be here. And we have some slides which. Okay, so maybe a bit of context. For about 3 years now, we've been running a research group at Stanford that seeks to improve the way we analyze and measure the productivity of software engineers, right? Or at least, get closer to that. And so here we're going to just talk about, a few slides that are quite relevant for this audience and for today, for PDD. And the first thing is kind of this, which there we go. So here we have a graphic which shows you, just diving right into it, right? The impact of AI on developer productivity, broken down into firstly greenfield, meaning new projects, versus brownfield, meaning existing projects, or like more mature code bases. And then in blue you have low complexity, and in red you have high complexity. So what's the takeaway here? Firstly, for greenfield and low complexity, huge boost, right? Up to maybe 100% sometimes. The median seems to be close to about 40 or so percent. However, once you move over to high complexity, the median then decreases a bit more, right? You're looking at like under 20%. Now, the problem here is in the brownfield part, and in the high complexity part especially, which is where most enterprises really are, right? They have these large code bases that contain a lot of stuff, lots of dependencies. And so we see the impact of AI on developer productivity there show much more moderate gains, between 5 and 15% typically. This isn't to mean that you can have higher gains or lower, and in fact, speaking of lower, if you see here, this is 0%, right? And you can see how some of the distribution is actually below 0%. This means that AI actually made developers less productive. And if you follow Twitter, there was also a small study published by this research group called Meter, and they found something similar, right? That sometimes AI can actually make us less productive. There's a lot more behind the methodology. I won't get into how we arrived at this, but feel free to reach out to me after this, and I can happily explain. Next, we have this, which is on the y-axis, we see the performance of coding models, right, from 0 to 100, and on the x-axis, context length. And what we see is that these, I guess, previous generation models, it's a paper from March or so of this year, their performance degrades with the length of the context window. However, when we look to the right, we can see that Gemini 1.5 Pro had a 2 million token context window. What does this mean? That despite the 2 million token context window, at 32,000 tokens, Gemini was already performing at half of its capabilities. Meaning that just because there is a big context window doesn't mean you can effectively use it. Applied to enterprises, what this means is that you can't just dump your monolith into the context window and expect it to perform well. It's actually going to perform quite poorly. And so then what this translates to is something similar to this, whereby we have kind of the estimated productivity gain on the y-axis. This is, by the way, illustrative. And then the code base size in terms of lines of code on a logarithmic scale on the x-axis. And you can see that as code base size increases, you can see the performance degrade. And this is going to improve in the future. But just increasing the context window isn't going to help us solve this, because kind of the transformer and the attention mechanism and like the transform architecture, the attention mechanism, they lose performance with kind of these larger context windows, right? And so I think if we're going to see gains and if we're going to see a move to this green line, it's unclear how we're going to do it, but I guess to some degree we will. And that's because, there's kind of a signal to noise ratio that's, the larger it is, the more noise there is relative to the signal. And so then to conclude, this is our research portal in case it's interesting for you to measure the productivity impact of AI on your organization. You can check out the URL. You can register to participate there as well. And then please feel free to reach out to me as well, either here or by email. Thank you so much.
So before Jonathan goes, just want to see if anyone had any questions for him. I think it's actually quite insightful in terms of his research. So we have a few minutes to take any questions. So does anyone have, okay, we have a couple of people who have, here, I'll give you the mic.
Hi, thanks. So I think I might have missed this, but how are you measuring productivity? Is it the lines of code or accuracy of the task or what?
Great question. It's a bit of a long answer, but we are not counting lines of code. We're not counting commits. We're not counting PRs. We're not counting store points. We're not using DORA metrics, because it's really easy to spit out commits and lines of code.
Yeah, exactly. Yeah.
What we're doing is we assemble a panel of experts that then labels commits based on how each commit, like on certain attributes like quality, maintainability, implementation time. And so we kind of use these commit to label pairs to train a model across various languages, which then means that by running this model, we're essentially replicating a panel of human experts who looks at code and not just the diff, but also the broader context of the repo, and then kind of tries and predict it. And right now we have like a 0.85 or so correlation to this panel. So think of it as having like a small army of people reviewing code and then assessing whether more quality and, like whether more output was delivered, accounting for quality and maintainability or not.
Next question had to do with your context window and the limitations. I'm sure you've done this and it's part of your research, but some of us in our coping mechanisms have cut up our applications into various pieces or smaller context windows and then had them aligned side by side or had them coordinated. Can you speak to that? Because right now we don't have a lot of options.
So it's kind of the question more around monolith versus microservices and whether, or is it just like, so artificially cutting a repo and then feeding it into the LLM? Well, I mean, these are like these creative workarounds that that people do in attempts to increase model performance. I don't know that there's like a state-of-the-art solution to this problem right now. Of course, lots of kind of agentic tools that kind of grab things and try and feed the right parts of the code base into the context window. But it's kind of like they're making it guesses, and many times they get it wrong, and they kind of grab the wrong thing and feed it the wrong thing, and then the code ends up being wrong, right? And then what's interesting is that in the past year, the gains we've seen in kind of like coding, agents and models have been mostly from scaling inference, right? Just letting the models think more. Now, there's research that suggests that for complex tasks, throwing more inference actually doesn't yield better performance unless the verifier model at the other end cannot verify whether this is like a correctly completed task or not.
Like a checksum in the old days.
Exactly, yeah, exactly. And so for tasks where we can't have like a good checksum, then actually more inference degrades coding capabilities, which is quite paradoxical.
Okay, we have time for maybe one more question, but I also want to let you guys know that there's a bunch of chairs back there, so feel free, you guys don't have to stand, you guys grab chairs from the corner, and then some people ask me where the trash is, and the trash is right here, so
So many of the cybersecurity companies I talk to just will not use any generative AI just because of the security issues. Have you done any research in that area?
So are they running these models on-prem or
On-prem, yeah.
and they would still not use them?
Yes.
Interesting. So we haven't done any research into cybersecurity and InfoSec and those kind of aspects. Lots of companies that we work with will just kind of like, if they have security concerns, they will self-host on the model on-prem and then run it this way, which means they're kind of limited to models that perhaps aren't the closed source ones, right, and which typically perform a bit worse. But maybe in 6 to 12 months, those models will catch up at least to where the state-of-the-art ones are currently. I think there's a lot of value actually in using, despite like these results of like negative performance and stuff like this, the trajectory is that AI is going to change the way we write software. We're not going to replace developers tomorrow with it, nor probably in the end of this year or probably end of next year, right? And as much as tech company CEOs tell you that, oh, we're writing 90% of our code with like AI and all this stuff, they're kind of doing this because that's their job. Their job is to sell their company, to sell a vision, to sell their product, to sell their models, right? They're not going to tell you, actually, yeah, the gains are a bit more modest, but like bear with us, just give us 2 years, and your money, and then we might get there. And so then there's like this tension between public, like if you are also a public company CEO or CTO, you don't want to go against the grain of like what the other, let's call it more prominent CEOs have said. And so then you get like this group think where everyone says, yeah, 50%, 100%, 200%, when in reality it's like a bit more modest. And once you talk to people at these companies, they're like, well, it's a tool, it's useful, it's helpful, we should use it, but it's a tool.
You also have this graph in terms of percentage of the context window used, and I think like 40% of this kind of rule of thumb that people suggest you should exceed in order to maintain productivity.
Sure. Could you comment on this graph if it were on the x-axis, percentage of context window used? Because there are kind of two reasons to think of it that way. First, obviously Gemini models will have very large context windows, and also I heard an opinion that you should never use more than 40% for your context window, kind of just operate and then compress, once you exceed 40% threshold for optimal coding productivity.
Yeah, great question. So, this paper, I'm not the author or not one of the authors. We just kind of had the opportunity to talk to some of these folks, and they kind of shared their thoughts on this. I think it's a really good point, and this is like the previous generation of models, right? Like 4.0, 1.4, 1.5 or so. I wonder if there's like an updated paper, but I think to your point, potentially if you make it as a percentage, you'll get like a slightly better picture, but still, with a there doesn't seem to be like a ton of difference. Like, for example, Claude which was considered to be one of the better models for coding, right? It has like a maybe middle of the road context window, and you can still see a lot of degradation in performance, right? Like once you hit, what is the 16%, you're down at 35% of capabilities. Maybe for the GPT models, there seems to be like less degradation relative to the context window. But I wonder if that's simply because they artificially cap it themselves, and then Gemini just sought to, hey, let's just make this a marketing differentiation point, even though it's not actually going to be that useful, right? Because like 2 million tokens sounds impressive. I think 2.5 Pro is actually only 1 million, so they might have over-marketed, but yeah. Hope that answers your question.
Okay, guys, let's give Jörger a hand. Thank you so much for your presentation. I think we also published, was it you that published about the zombie engineer or?
Ghost engineers, yeah. So this was very spicy. Last year we looked into our database and we found that about 9-10% of engineers worldwide in our data set are what we call ghost engineers, meaning that they perform less than, I think it was like, they're like in the bottom quartile of performance. They essentially do nothing, receive a paycheck. We later then looked at how many people hold more than one job, and I think the number we came up with was proven statistically 4 or 5%, so like worst case. And so, there's probably There's probably ghost engineers right here, actually.
No, I don't think so. I think these engineers are real engineers. These are people who want to learn new things, so I think it's okay.
Statistically, 1 out of every 10.
No, not. I think this is. I think in this room, no. But thank you.
Of course.
Okay, so just because I know some of you guys have come later, but there's pizza here, bathrooms are in back, trash cans right here, water over there. So help yourself, and there's Wi-Fi here too. So okay, so just out of curiosity, how many of you guys are software developers? Okay, good. A lot of you. That's perfect. That's the audience. Okay, so as I said before, my name is Greg Tanaka. I'm the founder of Prompt Driven, and I know right now that so many of you guys are software developers. A lot of you guys are really busy making code. And the really crazy thing, even though you're really busy making code, is that code is becoming disposable. And I'll explain why. So this is a slide from Andrew Ng. So Andrew Ng, he used to be a professor at Stanford, and he's done lots of amazing things. But one of the things he observed was that for like prototypes and hackathons, using AI tools like Lovable, Cursor, Cloud Code, it's crazy fast. It's like order of magnitude faster. I see a lot of shaking heads, so I think a lot of you guys agree. But the really weird thing is that it's almost like the tale of two cities. On one hand, for demoware, for hackathons, crazy fast. But for real projects, code bases over, let's say, 10K or 100K lines of code, kind of as Jürger talked about, you're seeing like much more modest. Like some people would debate whether you see any gains. So has anyone here ever run into issues with Cursor Cloud Code kind of going in loops? Okay, yeah, I see a few hands. Oh, it's more than a few hands. So a lot of you guys have suffered this pain. And this was kind of the impetus for the project. So this here is a picture of Cursor. It's probably one of the more popular agentic coding tools. And the main character is code, right? Code is the focus. And prompts are off on the side, there to patch the code. So the initial prompt maybe will generate some code, but after that, every subsequent prompt is there to patch the code. It's basically a very fancy patch. And so some people will patch it 1 time, 2 times. Some people patch it 50 times. Some people I've seen patch it like 300, 400 times. But what do you guys think happens as you patch code 300, 400 times? Anyone? What happens?
It breaks the other.
It breaks, yeah. What happens is you get the issue that Jürger just talked about, right? Where the AI tool starts causing more bugs than it's fixing, right? So it's a big time problem, especially as the code base gets big. So this kind of setup is okay for like hackathons and demoware, but it's not okay for real projects. For real projects, we'll take a page from Andrej Karpathy. So Andrej Karpathy has this super famous tweet, I think almost 8 million views, where he says the hottest new programming language is English. And so what we're doing with prompt-driven development is we're essentially flipping the script. Rather than the prompt there to patch the code, we're elevating the prompt to be the source of truth, to be the programming language. So just like in C, some of you guys might know C, just like in C we have that's the source of truth. You don't patch the assembly. The same thing here is with the prompt. It's a .prompt format, and then it generates the code. So instead of patching the code base, you're saying, let's regenerate, don't patch. Does that make sense to you guys? Okay, good. Now, what's the problem with this idea? Anyone? Like, why don't, okay, go ahead.
Well, if you're like editing the prompt and you're rewriting it, you're just devouring tokens.
Okay, yeah, so the one problem is cost. Okay,
I get the idea of a prompt IDE, but then you devour tokens.
Okay, why don't you go ahead?
Not deterministic.
Not deterministic, yeah. So that's probably the biggest reason. I think there's cost reasons, but determinism is actually probably the biggest problem. Is that every time you regenerate the code is different, right? And so it's hard to build a system that is reliable, right? Because like especially as the code base gets big, it starts causing more bugs than it's fixing, right? So not a good situation. So long time ago, decades ago, I used to be a chip designer. In fact, I designed the first commercially successful GPU. And at that time, people were designing chips using something called schematics. Anyone here ever do hardware design? Chips? Oh, wow, there's a few of you guys. I'm shocked. Okay, so so we used to design like basically drawing wires between transistors, and the problem with this approach is that as the chip started holding billions and billions of transistors, it takes a long time to draw those wires. So they started using something called RTL, which is a high-level like hardware description language. So instead of drawing wires, you could describe it in like more human-like language. And VHDL, Verilog, that's right, exactly. So, but the funny thing is, way back when people did chip design, they had the same issue where if you took the RTL and you resynthesized it, it would generate a different schematic every single time, right? And I remember the old timers who would tell me, oh yeah, this RTL thing is never going to happen because it's not deterministic. You can't rely on it. It's maybe good for, small things here and there, but you can't rely on it. And I was at a company called Synopsys. So Synopsys is a leading chip design company. It's a $100 billion company today. I just wish I held my stock, but it's a gigantic company today. And they basically solved this problem. So the bar for verification in chips is way higher than for software. For chips, if you get a single transistor wrong, it could be a mask change, right? It could be $100 million mask change, ECO. So it's crazy expensive. For software, if you make a mistake, just upload new code to the server, not a big deal. So this kind of determinism problem is a problem that we solved at Synopsys. And it took a while because it was a new methodology, but today, if you look at all the people designing chips today, everyone uses RTL. It is the de facto standard. And I believe that we could make prompts the de facto standard. And so what we basically did was we wrapped these LLMs, which are not deterministic, with a framework, a structure, to make the output of them deterministic. So the LLM itself is always going to be inherently like random. Right? We all know that. We've all experienced that. But if you could wrap it, kind of like what we did at Synopsys, you kind of wrap it with a methodology and tools, you can actually, oh yeah, that would actually be nice. A clicker, okay, great. Thank you, Leonard. Yeah, thank you, okay. So that's essentially what PDD is about, prompt-driven development, is to wrap this thing that's not deterministic to make it a deterministic flow. And I did a bunch of consulting over the past few years, and I've actually used PDD myself. So I used it for like the past 50 projects, and I had some clients that wonder how did I do it so fast? In fact, has said that I'm probably the most prolific AI developer as a result. So anyways, that's kind of like the story behind PDD. And I could go into more technical depth. I kind of wrote over a whiteboard here, so if you guys have questions, I could kind of talk about that. Yeah, I'm about to do the demo, but before I do the demo, I just want to see if you guys have questions about this. I can answer that before I get into the demo. So, questions. And we have one more mic here, which maybe, Leonard, you can help pass around. Questions, go ahead.
You mentioned wrapping the LLM, right? So if you have different LLMs, do you have to wrap each one differently, or can you use the same wrapper and switch out the LLM models?
Yeah, so I'm using a package called Light LLM. So Light LLM supports thousands of different LLMs. And so I support basically all the LLMs that Light LLM supports. So it's the same wrapper for all of them. And this project is open source, so you guys can go to GitHub and look at how I did it and contribute to it and see how it's done. Good question, thank you.
Great, thanks.
Any other questions?
Hi, Yuri. Quick question. How do you do evals on this sort of methodology?
Evals, you mean like benchmarking?
Right.
Like benchmarking different models, benchmarking the code.
I mean, on both, right? Like, you would need some sort of benchmarking to see the efficiency of your prompts.
Yeah.
Maybe how they're translated and stuff like that.
Actually, there's a white paper. So if you go to our GitHub repo, we have a white paper where we benchmark. In fact, I'm going to do a demo here, but it's not much of a benchmark. In the repo, there's a much more complicated example where we vibe coded with Cloud Code.
Right.
And then we use PDD to do the same exact thing. So it's like an apples to apples comparison. And I forgot the exact numbers, but I think in terms of performance, it was about 30 to 40% more efficient using PDD. And one of the reasons why using PDD prompt-driven development is more efficient is because essentially the description of the software is described in prompts. And what you have to think about is the LLM itself only has so much intelligence. And if you're stuffing in all the code, it can't optimize it as well. Versus when it's at the prompt level, it's able to optimize for the intent. So in general, one of the big benefits, besides determinism, that you get out of PDD is performance. You get much higher performance. So great question, thank you.
Thanks.
Yeah.
So one of the terms that's gaining popularity is spec-driven development. How's that related to PDD?
Yeah, it's very similar. So if you guys don't know, spec-driven development's been around for a long time, and there's a new tool out there called Cairo from Amazon that supports it. And the idea behind spec-driven development is you have a spec and it generates the code. And I think maybe one day when we have AGI, we'll get there. But for any meaningful project, anything that's more than a demoware or a hackathon, it's really super hard to go straight from the spec to code. And so PDD is what I think is kind of like the right technology for today's, where LLMs are today. So PDD is basically taking the spec, let's say a PRD, and then chopping it down into individual prompts. And then from the prompts, you generate the code. So spec-driven development skips one step. And maybe when we have GPT-10 or whatever, we'll get there, but it's not there today. Even unless you're things like make a snake game, you could absolutely do that. But if you're doing something substantial, anything that's worthwhile, it's unlikely to be able to do a very good job. Yeah. Okay. Oh, one last question. Oh, okay. So go ahead.
First, sorry.
I have a follow-up on that. I hear what you're saying about spec-driven development, but could one of the benefits of PDD being to require people to write a more complete spec? As in maybe we're misthinking the spec, not so much that we need GPT-10.
Yeah, I think that's a good question. So I think part of it is actually having a good spec, but I think part of it is, in PDD's methodology, the realm of the engineer, what the engineer developer is responsible for is the spec plus the prompts. Okay, with spec-driven development, it's saying, oh, the prompts, there is no prompts, you go straight to code. And it works for smaller projects. I'm not saying it doesn't work. It's not a valid methodology. It is a valid methodology. But when the projects start getting 100K, million lines of code, it gets crazy hard. Spec-driven development really breaks down significantly. And it really has to do with kind of what Jürgen was talking about. As the context window gets filled up, you get context poisoning, it starts really falling apart. But it's a great question. I think there's one last question.
Follow-up on earlier question around the different types of models that you support within Light LLM. What are the size of models that work with the prompt-driven? Are they the monolithic large ones from GPT-5 or down to like the open source NE type, 4B? What are the sizes of models?
Yeah, so it supports all the models that Light LLM supports, and I think they pretty much support everything, but I could be wrong.
Meaning performance, yes.
What did you say?
Performance-wise.
Performance-wise, yeah. So I'll tell you what I personally use. So in the example LLM model files that I have something like 18 different models in there. And so myself personally, I use all the biggest, best models out there, right? Sonnet 4, Gemini 2.5, GPT-5, right? All that stuff. But I also, on my computer, I run LM Studio, and I run like GPT OSS 120. I run the Qwen 3 model, right? So those are actually decent. So if you're flying, that's actually why I have that. So if I fly, I can actually code offline. Great question. Okay, so I think. Oh, okay. One last one. Go ahead.
Is there a hierarchy in the prompt development? You can imagine a situation where it's a really large project, and then you'd have to break up your spec either into like sub-specs or prompt and then sub-prompts, right? So a lot of times in Jira you would have epics and then stories. So I'm just trying to picture what the hierarchy would look like, and whether you would implement the hierarchy in the spec. Spec would have sub-specs, or on the kind of prompt side, the prompt would be broken down into smaller.
Yeah, I really believe in the concept that LMs have only so much intelligence per run. And so I think the idea of taking a spec and just one-shotting it like spec-driven development, I think is super hard. I think we're not there yet. And if you look at how the LM's performance has been slowing down, I don't know if we'll get there anytime soon. So I'm a huge fan of breaking down or partitioning. So I think if you think about what is the role of the software engineer in the future, I believe one of the roles is actually partitioning it smartly. So that's why I think the role of the engineer is to help partition. The LLMs may take a first cut at it, but the fine tuning of that partition, I think, is up to the engineer. So great question. Thank you. Okay, guys, I'm going to do a demo here, and of course we have networking at the end where we can also chat, debate, whatever. So let me try to get set up here. Okay, good. Oh. Can you guys hear me still?
Yep.
Okay, great. Table's a little bit low, so I have to kind of get close to this thing. Let's see here. Okay. Okay. So let's see. Can you guys even see this? You can't see it. It's too small.
Bigger font. Yes.
Okay, is it bigger? Let's see. Okay, now you guys can see it, right? Can you guys see it okay? Can you guys hear me? Do I need to make this closer?
We can hear you.
You hear me? Okay, great. Okay, so I'm going to give you a quick kind of trivial example of prompt-driven development. And this is prompt-driven development. This is cursor here on the side here. And I'm going to run PDD here on the other side. So, okay. Great. I'm just getting rid of the history here. So let me first explain what the prompt is. So it says create a single HTML file that uses the camera to draw with my index finger. So I can draw it with my index finger, erase with my palm, and select colors with a peace sign. Okay. So that's the prompt. And so I'm going to do a quick head-to-head comparison of Claude Code versus PDD. Now, for those of you that don't know what Claude Code is, it's probably one of the top agentic AI coding tools right now. So I'm just going to cut this prompt in, and then PDD it has 15 different commands, but sync is kind of like the Uber command. It runs all the different commands inside of PDD. So I'm going to run both of them at the same time, and we're going to do a head-to-head comparison. Okay. So as it runs, I'll kind of explain what PDD is doing. So the idea behind PDD is there's kind of what we call a dev unit or development unit. The development unit is a prompt, the code, the example, and the test. So these 4 files is a dev unit. And what this enables is it allows the developer to operate at the prompt level, right, versus at the code level. So the first thing it did, you might have seen up here, it was too quick maybe, is that it made the prompt a lot more detailed, because what it does is it runs something called AutoDeps, which tries to figure out what dependency, because this one's a computer vision application, so it dropped in the dependency. Let me just move this back up. Okay, so it generated the code, and then it generated an example, and what the example does, it runs the code to make sure that it works and not crashes, and it functions as the prompt expects, and then it generates a test here, and it uses something called formal verification. I'm not sure if you guys have heard of it, but it's a way to mathematically prove the prompt and the code are identical. So it generates a test, and it creates a very extensive test plan. And then the last step here is it will do a fix, right? So basically, it tries to make sure all the tests pass. So it will run the test on the code to try and make sure everything passes. And I have a really complicated diagram I'll show you guys later about how this kind of all flows together. But this is the basic idea behind prompt-driven development. And by doing this, so this is kind of like all the structure, the prompt and the LM. The LM is still not deterministic, but okay, so just finished. Oh wait, hold on, I forgot to. I should have ran this in dangerous mode. Give me a second here. Yes. Okay, I forgot to tell Claude Code to keep going, but okay, so you guys saw that. Let me try to bring up PDD to see how it did. Oh, actually, before I do that, let me show you. Okay, so you guys remember it started with just like a one-liner, right? Just a one-line thing about what the prompt was. And one of the important thing this does is it feeds back, looks at the code, and then updates the prompt. So it makes the prompt a lot more detailed than before. So so we went from one-liner to, let's see, how many lines did it do this time? About 103 lines. So it's a lot more detailed. So that's one of the premises of well, how does PDD make things deterministic? It makes it deterministic by having, first of all, a lot more detailed prompts. The second thing is it has very extensive tests. So actually, why don't you guys go ahead and you guys could move in, and there's more chairs and there's food here, so don't go hungry listening to you talk. Yeah, so it's a lot more detailed. And then kind of the other key thing, and I'll talk a little bit more about it later, is have you guys heard of the term few shot examples? Okay, so a lot of you have. So those of you that don't know what it is, if I ask the LLM to write me a poem, if I give an example of a poem, it will actually do a much better job in generating that poem than if it doesn't have an example, right? Just like any human. So we actually do that for PDD as well, and that's one reason why it performs a lot better, because it has, you can take an LLM that's lower performance and give it an example, and it'll outperform a larger, more expensive LLM. It doesn't have an example. Okay, so let's see how these things did. Okay, so let's see. Let's first check out. Oh, no. Okay, so let's see how this performs. Okay, so it's drawing. Can I? Oh, erasing. Oh, actually, the erase is there. Okay, and then can I select the colors? Okay, yeah. So it looks like I could select colors off on the side here. Okay. So I think PDD works here. So let's try, let's look at Cloud Code to see how it did. And by the way, this example I show here, this hand painting example, is in the PDD repo. So you guys can clone the repo and then run this yourself. Okay? So I have a few different examples of them. This is one of them. Let's go back to Cursor. Okay, so let's see how Cloud Code did. So it allows me to draw. Can I erase? Okay, I can erase, but it doesn't show me the eraser. And then can I select colors? Okay, it selects colors using the scrolling thing. Okay, so I think the color selection works, but it's just eraser. So let me go back. So one thing about, so I'm going to vibe code this, right? So one of the so with prompt-driven development, if this didn't work, what I would do is I would go back here and change the prompt. But with Cursor, what you do is you go here and you put a new prompt in. You basically patch the code base. So I'm going to patch the code base. Does this work? Except I can't see the eraser. Please fix. Okay, so it's going to, try to fix that. And then let me show you the overall PDD flow. So let's see here. Yeah, so this is the white paper I was talking about. So it has a bunch of benchmarks of performance between PDD versus Cloud Code and stuff. So you guys can go check that out. But the diagram I wanted to show you, is it too small? Can you guys see it? Is it too small? Okay. Okay. So the idea is you take a PRD and then basically partition it down to smaller prompts. So what's the realm of the developer is the PRD plus the prompt. And then, as the example showed, it starts off with auto depths. So it basically generates dependencies inside the prompt file. Then it generates the code, the example, and then it will, and I know this looks super complex, but the sync command does all of it. I'm just showing you guys under the hood how it works. And then you know, it verifies that there's no crashes. It will then verify the functional correctness, generate the test, then fix. And then once it fixes and knows that everything is okay, then it uploads the whole dev unit to the vector database for the few shot examples. And then last step is it updates the PRD and the prompts. So let's see how Cloud Code did. Okay. Oh, I should have started. So one little hack for you guys that use Cloud Code is there's a option called dangerous mode, and you just want to use that, so you don't have to do this. You don't have to keep pressing yes. I forgot to do that. Okay. So maybe while we're waiting for it's fixed. Okay, let's try to see if it works now. Let's refresh. Okay, so it kind of screwed up on the eraser. Okay, but the color, so it's just the eraser's messed up now. So let me try. See the eraser. It leaves a trail. Okay. So we'll let that kind of go, and then let me go back to the examples. So inside the repo, we have examples. Let me see if I can find it here. There's so many tabs open I can't tell. Okay, well I'll just go back to PDD. So this is the repo here, and by the way, I put QR codes all over the place, so you guys can look at our Discord, our repo, all that stuff. So. But in the examples here, we have the hand paint example, so you guys can. So the hope is, and we're passing out these T-shirts to everyone that gets it installed and runs the example. So you can run the hand paint example I just did. We have this hello world. You know, everyone has hello world. We have PyCalc, and then also on the back of the T-shirt. On the back of the T-shirt, you might see this kind of fancy QR code with a picture. So you guys can create this yourself using PDD. It's one of the examples in here. So you can put any URL, and tell any picture, and then it creates a kind of a fancy QR code. So anyways, so incentive to try out the tool. Okay, so it says it's fixed. Let's give it a shot here. I could draw. Okay, I can erase properly. Okay, so everything's cool on the Cloud Code side now. Now, one unfortunate thing is Cloud Code doesn't. It used to tell me how much it cost and how much tokens you use and how long it took, but it doesn't do that anymore. But if I did do that, if it did have it still, it would be in this case probably about three times longer and 5 times more expensive. So I think someone out there talked about concern about cost. So one thing about these agentic coders is that they're very token inefficient, because most of the tokens that's being used isn't to generate the code, it's actually to do the agentic flow. But one nice thing about PDD is that you have full control over the context window, and virtually all the tokens that are being used are used to generate the code. So it's much more token efficient. And by the way, there's lots of pizza here, guys, so if you help yourself, water, whatnot. Okay, so let's move on in the presentation. Okay, so we're on the next one is ToolHouse. So let me read a quick introduction. So I want to introduce our next speaker. This is Daniel. He's also a 500 global portfolio company. He's the Chief Vibe Officer at ToolHouse, which I think means he's CEO. He built open of the most successful developer products at Twitter and survived 3 CEOs, including Elon Musk. Before that, he was at Meta, and he was part of the team that made the money to purchase Instagram. So we all should thank him for being able to use Instagram. And also, just as a side note, he's he's been a bit of a mentor for me. I'm kind of newer to the dev tool space, so thank you so much for helping me, Manjari. So give it a hand for Danielle.
Hi, Daniel. I got myself set up. What's your favorite fruit? Lychee. Lychee?
Grapes.
Grapes. So mine is watermelon. Why did I ask this question? Because we have this most delicious fruit in our hands, and we throw the core and the actual juicy part, and we eat the rind or the shell. That's what we've been doing with code and prompt. So that's why I'm so happy to be here. Thanks, Greg, for for putting this together and having me. Because prompt is the future. Like, I was an engineer. I was at Greg. I come from the nerdy side, computer science, and then I figured out that's what people are doing. Like, they're actually generating prompts, generating the code with the prompts, and then throwing away the prompts. Like, nobody put prompts under version control. They do evals, sure, they do some variables that works, but that's it. So I think this is the future. So I'm super excited, super bullish on PDD, and I think Tools is super relevant to that. So before I give you what's Tools and what's all about, that's me chasing bugs, because Chief Vibe Officer. I think everybody loves to hate on vibe coding, but I think there's merit to it. I don't code anymore, and I should be. What I do instead is I type, I get the code, I test it, I review it, but still, the prompt is king. The prompt is where it's at right now. So that's me chasing a bug on vacation. Like a bug that really landed. I fixed it, I didn't squish it. I'm vegetarian, so I can't do that. So if you head over that table with a tablecloth with our logo, you see this. What's this? It's a ticket to the future. Exactly, ticket to the future. If you have it, you're in the future. And I'll show you what the future looks like. Greg already showed you a part of it, and I'm going to show you the rest with Tools. So people have one problem, one big problem. And it's 2025, and despite OpenAI raised, 60 plus billion? I'm looking at my investor because I want some of that. And Anthropic just announced at the raise, there's still a fundamental problem. My agent works on my laptop. When I close my laptop and I go to sleep, it doesn't work anymore, or it doesn't work as reliably. So we're here to fix this one problem. And while we try to fix this problem, we bumped into an additional problem, which is a ton of people, and I see people in this audience who already bumped into this problem before. They don't even know how to prompt. And so they need to understand that there's no barrier to prompting anymore. So we solved those two things. Help me build an agent without me figuring out how to become a prompt engineering or figuring out prompting techniques. And the second part is help me put it in production as an API with the same reliability as, well, not just my laptop, like the cloud. And that's what we do. So you build agents with a CLI and a UX, and you deploy them as APIs. We have a very small interface. We're not a Lovable or a V0. We do have just a fixed interface that you can use for your own convenience. You can embed into your website, but we do have a prompt generation part also in the CLI, which I'm going to show you in just a second, that allows you to teach any vibe coding or any other CLI you use, Grand Code, Cloud Code, which Greg mentioned before, Codex, how to connect to Tools. But it's an API, so it's very simple, so I'll show you what the prompt looks like later. So today we're going to build something real quick, but I'm not going to show you code, I'm going to show you the prompt. And I think this is the immediate realization that people in 2024 should have taken, and they didn't. And now it's 2025 and it's all prompt, and we're seeing a ton of shift in the industry, and the shift is going to go towards this direction. Prompt first, somebody else will do the infrastructure or the tools or the frameworks to convert your code into prompt, and then the prompt is going to be the source of truth. Same here. I'm a co-host / guest in reality, so guests never go empty-handed. You have plenty of this QR codes around. This is to get 1 month free of Tools. So you sign up. This is just the link to the sign up, so no credit card required. And then if you want PDD 100, you get 1 month off any plan, but it's only 1 cent a call. So you start with $10 a month. Then if you want to go crazy, there's up to 500, but you don't have to. So, but that's the link. And you also get free LLM tokens. We don't charge for tokens. So Toolhouse is the first agentic backend as a service. Think of it as what Vercel did or Cloudflare did with Workers, but specific for AI agents. So we build the infrastructure behind the scenes to make sure that it works. If it works, you're building an agent, it works on the cloud, and you can reliably make it work. This is just one on the part. I'm not going to do like complete walkthrough of Toolhouse. You can observe every single run down to the MCP server calls, tool calls, input, output. Behind the scenes, we keep state for each one of the runs you have. So it's when you have a database and storage already built in. There's a RAG built in, so you don't have to reinvent the wheel or try to figure out the puzzle. But you can bring your own stuff as well. So it's completely flexible. And that's the actual screenshot you might want to take. That's how you get the CLI installed. So CLI is also open source, and it allows you to do pretty much what you do with the UX. All right, so you're going to see our CLI commands printed on my hoodie. THVibe is one, and then I can see because you're a lot. Pete from our team over there, he's TH deploy. So he uses the CLI. He actually won a hackathon with the CLI, deployed his agent, showed it, got a job at Toolhouse. All right, I'm going to show you a few things from the very basic examples, and then we're going to add up, and I'm going to show you the importance of building for the prompt. So, without further ado, first of all, I'm just going to type like I'm at home, use this. There you go. You can still hear me? Yep. So it's super simple. You can do something like build, let me build this up a little bit. Build an agent that searches X for trending news about the specific products, and then sends me an email with the summary. So this is Agent Studio, and that's the first part, the first problem we're solving for everybody. Like, people don't know how to prompt, we prompt for them. And that's how it works. So in real time, we had code and prompt that's being built by Toolhouse itself. There's actually behind the scenes an agent that's actually also built on Toolhouse, that's taking what the user is trying to build, and then creating the prompt, an agentic prompt with steps. Obviously, this agent is trained on Toolhouse, knows what we're capable of, and understands how to write the prompt. And so this is the prompt, and this is your new code. We don't have a code editor, we have a prompt editor, and you're good to go. So in 30 seconds, you build something that already connects to X and fetches latest tweets about something, and then it can send you an email about it, and you didn't have to do anything. And on top of that, you can also add your own MCP servers. There's another agent also built on Toolhouse that connects to an MCP registry, our MCP registry, and connects you to any additional capability you may want to add. So for example, I can also type now, actually, instead of email, can you write the summary to Notion? And you're going to see that the MCP server will change to Notion. There you go. And here we're basically overcoming a fundamental problem with people that, how do I build integration? How do I actually teach the agents to connect? There you go. Now all you have to do is to put your API key. I'll actually show you one of the agents we built that we also use internally. And that's the
Daniele,
one. Yes.
Are you taking any questions?
Yeah. I'll stop actually.
Never mind.
Oh, all right. But yeah, shout if you have any questions or raise your hands and I'll do it. Don't let me, I can talk for a long time. All right, so I'll show you this one prompt. Actually, one thing, this is your file. It's a YAML file, so you can download it, or you can put it on GitHub under version control, which we do, obviously. So this is your new code. From here, what you can do is to also, every time you commit a new YAML file, you can trigger a GitHub action that can test this prompt on a 2-hour sandbox. And if it works, if it passes, then you can deploy it and you have a new version. And you can roll back as you roll back your prompt. Super simple. So from here, I'm going to introduce you the TH CLI. So super simple. You can do the same thing we've been doing from here. So TH new. You can just get a template file. And here you have complete freedom. So we just created this agent with this name. So I'm going to just open it. Call me old-fashioned, I still use VS Code. There you go. So as you see, there's obviously a YAML schema. You have the same fields you had before. Super simple. And from here, we can start changing model, system prompt, adding variables, adding our own MCP servers. You don't have to pass from our gateway. You have complete freedom here. You're just hosting your agents and running them with reliability. So one thing we did for our team is a growth task reminder. So our growth team has a ton of tasks. We are now 4 people working basically full-time on growing the community, which is why you have also the QR codes to our Discord community. And what we do is to get all our tasks on Notion. I'll actually show you what the page looks like. We basically have a tracker here with upcoming events, upcoming dates. And so each day we have a schedule from here, from our schedules. You can just set up the cadence you want. So cron, right out of the box. Every day the agent comes into this page, looks who should be doing what, and goes on Slack and reminds people of what to do. And this is what it did today, every day at 10. So I had to do something for our upcoming MIT hackathon. Then I had an event today. I hope I attended it. Pete, did you attend the prompt-driven development event? All right. And that's our super simple prompt that's actually very powerful because it connected Notion to Slack with just words. I'll show you for reference.
Yeah, I have a question.
What was that? Yes.
So why are you choosing YAML as your prompt saving file? Because making changes manually on an YAML file is very tedious for a human. Just curious. Is
Yeah.
there any particular reason that you want to go with YAML, or a better, more reliable one can be?
Yeah, we had different options. One was JSON, even worse. One was Markdown or text, which is unstructured but doable. We wanted to give developers some structure, and so when we talked to our community, they wanted something intermediate. So they understood that even if YAML is kind of cumbersome to edit, especially when you have multi-line stuff, if you have a good VS Code extension, for example, you can get by pretty quickly. And the other part was that Agent Studio is the most used functionality within Tools, and so people actually want to interact with their prompts directly from here by talking to the agent, not necessarily by changing or creating the prompt directly. And so they want basically a source of truth, a reference point that they can put under version control every time they click publish, which, by the way, I can show you. So when you publish, you have an interface that you can use, and this is just our stock interface that you can use to talk to your agent real quick. You have APIs, So your agent is also an API that you can call directly. So if I can copy this and paste on my terminal and run it, this would probably, oh, I need to run it from my other account, sorry about that. There you go. I have other credentials on the CLI. So I need to run this one, publish it. Oh, there you go. So from the API, I run this one instead, and you're going to be able to run an agent, and this is in the cloud. There you go. This creates content for our team. So it gets into our documentation, reads what the what Toolhouse does, and we basically tell the agent, hey, pretend you're actually a user and think of an app you're building with Toolhouse, read the documentation, and come up with super tough questions or praise. And then the result are 10 posts for Reddit. There you go. And then we go and we can post. This is also some good inspiration. We have agents like this at work to do our blog posts, to do our emails, to do basically all our marketing. Our customers also use it for lead generation. Like they get search results for stores they want, and save vet them based on some criteria that they give to the agent, and that's where they have to edit the YAML manually, and then they get the leads and put it on HubSpot through the MCP. I see a hand there.
Yeah, quick question. So, is there a way or tools to actually check whatever I put the prompt in for the AI agent to do? How do I verify without actually manually going through the process all the time? Are there tools that you guys have or other tools that you use to do that?
Yeah, the beauty of this is that you get a sandbox environment. So there are a few things you can do. Like you can create an entire pipeline to test out stuff, or usually the changes are actually really incremental. So you might want to do a few tests from some messages that you have. So you want to make sure that if you're changing the prompt, the input that the user is giving the agent yields the result you're expecting, and then it fixes the unexpected results. So what people do is they plug this into their eval frameworks usually, or they just write scripts to feed the API with different messages, and then they eval, they get the output and they eval the message. Another thing you can do is once you run the agents through the API as well. There you go. I'm going to show you what happens if I run this with verbose mode. You get a header, which is your Toolhouse run ID. And this basically, you can reference this again, and you get the entire JSON payload with any NSP code that's been made, the chat history from the user, all this kind of stuff.
So I can feed that in.
Yeah, you can feed that in and you're good to go. So yeah, if you want to export all the data, perfect. That's you're in full control. Another question?
Cool. This is awesome. I totally want to use this when I get back. On the flip side of that, like when you see the prompts that don't properly transition into, and we don't see the code right from that side, where do you see the limitations that you if you could have another year of development with your developers and make this better, where are you currently seeing the kind of areas that may break down for the people using it, if that makes sense?
Yeah, it's really on their internal integrations. We have obviously a ton of control over the prompts for each one of the MCP servers we have. We have control over, we optimize every single system prompt based on the model you use. And so you can get consistent results even if you change the model. And I'll show you that in a moment. I'll show you how to chain agents together and create a deep research agents with Toolhouse. And I think, the limitation is obviously if you have internal systems and you plug them to Toolhouse, then you have to spend a little bit more time on the prompt, on the system prompt specifically. But some of these companies, we partner together to really consult on and teach them how to do that better. If there isn't, if they give us, for example, an open API spec with their internal services, then they can train an agent to work with the integration. Because in the end, that's tool calling. The agent can code the tool to run those APIs, on behalf of itself, then your description for each operation in the OpenAI spec, getting confused, needs to be very precise. So that's where things get blurry, but those are like super advanced use cases. Yeah. Yes.
How can I check the outputs of each agent run in Agent Studio?
That's Pete. And I'll answer the question in a moment. I have the question here in the front.
Yeah, so do you feed,
Thank you, Clayton.
Thank you. Do you feed YAML directly to LLMs or do you transform it before it goes?
No, those are transformed. This is just a source of truth. So the YAML is a reference point for you to put under version control, and it allows to hydrate the API call we made to the generation service we have behind the scenes. So we don't feed that directly to the agent. We just we parse the YAML, and then each one of the parameters have a purpose. So for example, this is an example, and it's a good segue to the deep research agent because it uses variables, and I can show you how we basically extract the information, parse the YAML, compose a prompt, and then send it to the agent. But first, I heard a question from the back from Pete.
I have a follow-up.
Oh, yeah.
So what do you call it? So the prompt is actually generated. What are you calling the YAML file? Is it a spec? Is it like, what are you calling, like, what's the name of this thing? Because it's not the prompt, right? The prompt is generated.
Yeah, it's TH file, TH from Toolhouse.
Okay.
Yeah.
But would you call it a spec? What would you call it? Like in terms of like classifying it?
Yeah, it's a spec. Like, yeah, we have a schema for that. So there's a schema for the file. Yes. Last question, then I'll move on to the deep research agent. Pete, what was that?
How can I check the outputs of my agents in Agent Studio?
How can I check the output of my agent in Agent Studio? All right, there are a few things that you can do. There's this preview sandbox that you can use. So once you try out, generating the first prompt, you can start typing here. So let's say, what are people saying about OpenAI? And you can see, I'll use another one because I was messing around with this and I don't want to end up in Notion or an email. So I'm going to generate a new prompt that says, create a new agent, builds an agent that searches X for a trend, for a topic the user will provide and summarize it. Then send the summary via email to the email the user will provide. All right. So the preview tab is where you get the output, but as you run your agent, you see all the runs here, including MCP server calls, the output. So this is exactly the output you will get from the API as well if you wanted to get the entire JSON payload, like I was mentioning before. And perfect. Please search X for relevant news about OpenAI and send those to me to any other Toolhouse. Yeah. So this is where, like, we haven't published this agent yet, but we're testing it out in our sandbox. There you go. No, this is cool. Send it. So see what happens here. There's a little bit of a behavior I don't want. I want the agent to be more autonomous than this. I want the agent to tell me, just like get the news and send it to me. And so now I can go back to the left-hand side and tell Agent Studio, hey, can you make the agent more autonomous? It should send the email directly as soon as the user provides it. So now it's sending the email, and you will see, I'll see it already here. It's going to be somewhere here. Here's my expenses. Sorry about the mess in my inbox. There you go. And that's the output from Toolhouse we just generated. So along those lines, you can actually do something a little bit deeper than that, and you can combine stuff together, and it's super cool because it's all about just like some prompts and a little bit of JavaScript. Like if you use Node.js and this is all API calls, then all it takes is a little fetch and some promises, right? And that's what I did. So I built this agent that does deep research because I don't like the term deep research, and I think Perplexity is selling us this term just to hype themselves. And so I was like, let me see if I can actually do it myself. Like, what is it all about? And thankfully, we partnered with Grok, and we did this in live stream together. And they have this nice model. It's called Compound. Compound is basically a flavor of Llama that runs tightly with Tably web search. So they have web search integrated and super fast because they have fast inference, and Tably is hosted closer to the data center, so it's like that. And look at what I did. This prompt is super, super, super small. Return a brief summary of recent announcements from the company mentioned by the user. Your search query should be related to product announcements, and the message is OpenAI. So back to how do we parse this YAML. So when this runs, and I can run it directly with the CLI. So if you go back to the CLI, I'm going to go to Grok. Those are the agents we have. So now I'm going to run this roundup agent, and it's going to use Compound to search the web for OpenAI. Run roundup. So here you see the parsed YAML file with all the parameters we added. There you go. It didn't say much because maybe it didn't find new pieces of news. That's totally fine. So we can also try and find a different model or add a different message. But what you see is that we took this and we parsed it and we added all we needed here for pretty much everything. All right, sorry, I actually ran the wrong agent. It was Compound search I hit run, sorry about that. Okay, so this is now using Compound, yeah, perfect. So we prompted with just OpenAI, just one keyword, and it searched the web, GPT-5, image generation API, right? So those are like results that come from Grok, super fast, perfect. Then the idea is that we send a different message per each agent. So we can do Anthropic or Perplexity, since I mentioned it, you know. Let's see what they're at. So this changed, and obviously you get the gist. So we're testing. This is exactly the same concept as the sandbox that I showed you before. So this that we're doing is this one with extra steps because it's a CLI. That's it. So, and now we have this roundup agent that takes all these calls to the Compound search agent. So I can basically now spawn through promises 5, 10, 11 different calls, get all the results, just like glue them together and send it to this other agent that's going to summarize them and send me a nicely formatted email. And to do that, I'm going to do just a little bit of JavaScript. This is vanilla JavaScript, really. So we're using fetch, and we have just this nice tiny wrapper around fetch, which we call Toolhouse.js. Those are the two agents that I deployed. So let me show you the deployment of those agents. Deploy roundup.th, deploying it. Perfect. So you have the URL here to the agent and curl command. And then if you want to open it, you can just open the widget, we call it, so the interface. So you can also chat with that. You could also do more. So you can run thvibe on this agent, and it will create not a YAML file, but a prompt that then you can paste into Lovable, Bolt, V0. Let's try Lovable, for example. So this is the prompt. It teaches Lovable in a one-shot fashion how to integrate with Toolhouse. So I press enter to copy it to clipboard, opens Lovable, it's already there. boom. And now I can create an interface for this specific agent like that. Thank you. All right, but now let's run these two agents together. So I'm going to create this newsletter like this. So those are the agents that run together through promises. We saw that fulfill the promises, done the research. This is the results. And now this is sending an email to me, which hopefully will arrive pretty soon. And as soon as I have it, I'll show it to you. All right. Let me see. Roundup. Yeah. So this is, and while I wait for the new one, I'll show you a previous one. That's it. So, and that's done with a few lines of glue in vanilla JavaScript and prompt. So that's basically Toolhouse in a nutshell. That's what it can do. We haven't touched the line of code. We touched a ton of prompts. This goes under version control. This is basically our new repo, and the rest is our infrastructure. Questions? Yes.
Where does the user see the version control for the prompts? Is there like a UI where they can just go back in time and then see what prompts they've been like editing or?
So the question was, how do you go back in time and roll back from the UI? You just do that through the CLI, so you put that in the version control, but we have a roadmap for rollbacks, and it's actually feasible today. We just need to create the UI for it. So you can go back and forth. Another thing you can do actually, and that actually was something that our customers told us to do. They say, so they will go back to Agent Studio and they say, oh, sorry, I didn't mean to do that. Can you roll back of 2 messages? And I want the YAML from 2 versions ago. And it works.
Can you handle hallucinations? How do you handle that, especially with agents running in loops and other types of things? Hallucinations is a big issue.
Yeah, so our system prompt already mitigates those hallucinations by a ton, because it gives, it has already a ton of additional guardrails on top of what the model provider gives you. Like, for example, it gives tools and out. It doesn't really call indefinitely all the tools. And then the second thing is because you have now actual data, so when you fetch data from the internet, the LLM, the underlying LLM and the agent has a reduced tendency to invent stuff or to make stuff up, because it has some ground truth, so it has some grounding. Same when you upload stuff through RAG, it reads RAG, and so it has a better context and understands better what's there. And then lastly, we have the ultimate safeguard, which is bundles, and I'll show it to you. Bundles are basically groups of tools that you can add or remove. So especially as you use faster models or models that don't reason, the less intelligent model, or the less reasoning the model does, the more prone the model is to call the wrong tool or multiple tools or do multiple calls that are not needed. And so, for example, if you are searching something on the internet, we have 6 different scrapers, and the agent, for example, this used to happen a lot with the 4o and nano models. You will see the agent using the scraper when it meant to use web search, and eventually it got there, but you want to get straight to the right result, right? And so you can set up a bundle that says, hey, I only want search, I don't want scrapers. And so you toggle stuff on and off to just tell the agent, I only want those tools. And that is greatly improving the the performance of the model when it comes to hallucination, especially on server calls or tool calls.
Quick question. I saw, and my apologies if you explained this later, before.
I saw an example where you have the prompting and then you have the message. Do you guys have support for for a more conversational base where you can entertain the whole chat with the user?
Yeah, you actually saw it, like that widget, the interface when you can talk.
Right.
That's yours. Like when you hit publish, you have your own URL with that interface, and that, like, you can put a Stripe link on it. You can reskin it if you want, and it's done for conversational use cases. So we started with agentic only, autonomous, runs at night, you know. But then we figure out if we do that, then we miss out on conversation, and this kind of pattern is very useful for conversational use cases as well. So we started to figure out, can we have a more conversational interface, and that's what we built. The API as well. So the first request is a post, as I showed you. But then if you want to continue the conversation, let's say you want to build an API, a chatbot interface, right? Which is what the Vibe coding prompt, by the way, does. See what the prompt looks like. When the user first sends a message, call post on this with a JSON payload.
Right.
Store the X to allows run ID header, the one that I showed you before from curl. Let's see if I can pull it up. There you go. So we expose this. This is basically a session ID, if you will.
Yeah.
And it identifies the run of the current conversation between the agent and the user. And then on any subsequent user message, call put run ID, where the run ID is obviously the one that you got from before. So you start a conversation with a post, it gives you back a run ID, and then you start doing puts on that new URL to put new user messages and get data back.
Gotcha. Okay. Quick follow-up. Many common scenarios with conversational chatbots have this. Is it on your roadmap to support some sort of state persistence on Toolhouse, so you can have common utilities that you need in conversations, like collapsing frames for the context and stuff like that? Is it that kind of roadmap?
Yes, and the due date for that is last month, because it's
okay.
done. So it stores, like, those agents are all stateful, and the other thing that happens is you can make an agent that has, they can also share memory with other users, or every user you can identify, give your own user ID.
Okay.
And each one will have its own siloed partition memory and partition states. So here, like, you can have, and this is useful, for example, for use cases where you want to connect agents together for internal use cases. For example, there's a customer that does lead generation and has two agents. The one agent crawls the internet for specific retail stores and needs addresses, physical address or email address, and needs to store that in memory. And then needs to store the last page of results it used, so next week it can resume from where it left off. And then the second agent needs to understand the new leads and then check the CRM if the leads exist. And so they need to use the shared memory.
Right.
So to do that, they use the same identifier for the internal user. And an external user-facing conversational agent will need to have one memory per user. And so you can pass a user ID, which we call Toolhouse ID, which allows you to do exactly that. So you can basically get memory siloed for each one of your users and isolate everything.
Thank you.
Yep. I'll wrap it up here. We're going to do more networking, so ask me any questions. I want Greg to, wrap it up and show you exactly what this looks like. But last chance to get the QR code. Greg, so yours.
Awesome. Okay, guys. I'm just for interest of time. Let me speed run this. Where is the? Okay, so I have a demo, but I'm not gonna go through all of it, but does anyone here remember what was the main use case of C when it was started? Some of you guys are probably too young to remember.
To overcome the assembly language.
Yes, it's assembly, but more specifically, does anyone else remember?
Or English type.
What would you say?
Phone system?
Phone system, oh, kind of. Where I was trying to get to is actually migrations. So being able to go from, let's say, 8086 to ARM to PowerPC to do a whole bunch of other things. So that's actually also one of the main use cases for prompt-driven development, because you're working at a higher level, you're working at the prompt level. And so this allows you to port to, let's say, different clouds, different frameworks. Let's say we run Rails to Next.js. I have a quick demo here, and I was going to show it, but I see people getting antsy, and we have a lot of pizza left, so people probably want to get some pizza. So I can show the demo later if you guys are interested, but I'm going to kind of skip that part and just talk. That's what the demo is about. It's basically you take a GitHub repo link, and then automatically converts it to a different cloud, a different frameworks. So that's what that is. But we're going to skip that just for time. The thing that I think is really important, and the reason why we're having this launch party, this project is open source. This is a new methodology. And what's really important is community. It's actually all of you. And this is why we're holding this, and we'll probably do other ones. But the idea is for all of you guys to actually get involved. So this is some of the principles, like the 7 principles of PDD. And it's I'm not sure if you guys, have any of you guys seen the Ruby on Rails doctrine? Some of you guys, okay.
Dry, conventional configuration.
Yeah, so this is kind of like that for PDD. Some of them are somewhat, not that different. Like test accumulation, people kind of do that already. But some of them are new, like prompts as a source of truth. So there's a lot of them here. I put this up because this is the part where we go into networking, and I want you guys to actually discuss this. So should prompts be the source of truth, right? I have a whiteboard here. You guys can just talk with me, debate it. I have another one here, which is regenerate, don't patch. Right now, pretty much everyone is patching, right? Everyone's using Cloud Code, and they're basically using it as a patcher. I'm saying that's not the future. We were taught in engineering school not to do ECOs, yet that's what Cloud Code and Cursor are doing. Synchronization loop. The idea behind PDD is that everything's synchronized. The whole dev unit and different dev units are synced up to each other. Modular prompt graph, basically using examples as they include, so you have a smaller, more efficient token window. Having intent and batch first workflow versus interactive. So this is just some ideas for you guys to have. We try not to have too much us just talking. We wanted to have more community and for you guys to actually talk to each other and to debate, what's good, what's bad. I can't pretend to have all the answers. This is a very new methodology, but it really involves all of you. You guys getting involved, trying to use this, create issues on GitHub, do pull requests. So this is really meant to be kind of a community for you guys to kind of meet each other, say hi to your neighbor. And we have a few volunteers, so we have James back over there, and a few other volunteers here who will be passing out these nifty T-shirts here. And before that, Grok is sponsoring $20. So anyone that wants $20, I have the QR codes on the wall too, but you can take pictures of this. All you have to do is post a picture of this event onto the LinkedIn link here, and then you get $20 credit. So please do that. They've been very generous about this. And the other little promo we have is this T-shirt. So basically, just install it, try to run an example. We have a few volunteers. James, he's wearing one of those cool T-shirts. We only have 50, so the first 50 people get the T-shirt. And then instructions are on the wall here too, so you guys can look at that. And then, my LinkedIn. My LinkedIn's also on the wall. So just wanted to thank, I know everyone is busy, you guys are taking time out of your evening to be here, but I really believe that this is the future of programming. This is how we're going to be programming the future, is through prompts. And you guys are really kind of on the cutting edge. And so looking for you guys to be part of it, to contribute to it, to tell me what we got right, what we got wrong. But this is an open source project, and really we're having this, and we're having it live because we wanted everyone to be here to discuss it. So this place is going to be open for a while. There's still a lot of pizza left, still a lot of water left. We have a lot of t-shirts left too. So, and stickers. So really, the bulk of this is really for you guys to talk to each other, talk to me, talk to any of the other volunteers. Oh, there's James right there. You can wave your hand. So he could help you install it. We have a few other people who could probably help as well. So reach out to them. But want to leave this time open for you guys to chat and mingle and get involved. So thank you guys so much for attending tonight. I really appreciate it.
We did it.
David.